Let's talk about series. Now, I want to remind you of our motivation. Really, for us, our end game is we want to work with functions. In order to work with functions, we actually need to study something called power series. In order to understand power series, you have to understand series. That's what this video is about. And for us to really be able to talk precisely about series, we need to learn about sequences, which is what we learned about in the last few videos. Now, just as a quick reminder, an infinite series, that's really an infinite sum. So that's going to look something like A1 plus A2 plus A3 plus, and it goes on forever. And our goal for the next few sections is to determine whether an infinite series converges or diverges. So why don't we look at a few examples? In example one, the general term is just zero. That means the first term is zero, the second term is zero, the third term is zero, so on and so forth. And you keep going on forever. And I hope you can see that if you kept adding zero to itself forever, you would get the number zero. So this would be an example of a convergent sequence. And I think that one is fairly obvious. Let's take a look at example two. In example two, the general term is one. So we're going to take the number one and keep adding it to itself. So it's going to be one plus one plus one plus, and it just goes on forever. And if you imagine, if you keep adding one to itself over and over, you're going to get an infinite number. You're going to get infinity. And this would be an example of a series that diverges. But this next series, example three, this series is a little bit more interesting. So if you take 1/2, that would be the first term, and then you add 1/4, which is the second term, and then 1/8, which is the third term, and 1/16, and you keep going, what are you going to get? Well, in this section, we will see that you're going to get this number 1. So this is going to be a convergent series as well. Okay. So I can explain this one particular example with a picture. So let me do that. Let me draw a line here. Okay. And I'll label one side of the line to be 0 and the other side of the line to be 1. So I want you to imagine that in the first step, you go halfway. So that's 1/2. And then in the second step, you go half of the remaining distance. So that's 1/4. And then in the third step, you go half of the remaining distance. That's 1/8. And the next step, you go half of the remaining distance, that 1/16. And I hope you could see that if you keep cutting that distance in half more and more and more, you're going to eventually get to this number 1. You're never going to get there, but you're going to get closer and closer to 1. In other words, the limit is going to be equal to 1. All right. So what we want to do is we want to say, okay, I understand these 3 examples. What about a more general example like 1/3 to the n? I think this example is not really so obvious as to whether it converges or not. So we really want to study in this particular video, how do we formally define what it means for a series to converge? Okay. And in order to do that, we are going to have to look at a new definition. We're going to have to study something called the nth partial sum. Now, the nth partial sum is denoted S sub n, and it basically adds together the first n terms. So what I'm going to do is I'm going to change my index to I, like this, and I'm going to have my upper limit of my sum be n, and then I'm just going to add together the AIs. Okay, so if I were to write it out, that would be a1 plus a2 plus blah, blah, blah. And the very last term would be an. So this is the sum of the first n terms of the series. That's what it means. So let's take a look at a bunch of different partial sums. So S1 just means, you know what, I'm just going to take the first term, A1. What does S2 mean? That means add the first two terms. So that'll be A1 plus A2. And S3 means add the first three terms. So it'll be A1 plus A2 plus A3. So I hope you can see that Sn would be A1 plus A2 plus A3, and then we just keep going, and then we finish with An. So that's what I had wrote earlier as the summation as I goes from 1 to n, A sub I. So when you have this, these nth partial sums, then what we can do is we can look at them as a sequence. So, we want to look at the sequence of Sn like this, okay? So in this case, my sequence, that's the first term of the sequence, the second term of the sequence, the third term of the sequence, and so forth, all right? This is what we call a sequence of partial sums. So what we are going to see is that our infinite series converges if the sequence of partial sums Sn converges. So this sequence of partial sums is used to define convergence. Okay, and I should probably mention that if Sn does not converge, we say the series diverges. All right, so I'm going to highlight that little diverges part there. I'm going to highlight the fact that we need this sequence of partial sums, Sn, to converge, which, looks like I just highlighted the whole definition. But that's really what we mean when we say it converges. So in the next video, we'll be looking at a special case, a very important special case of a infinite series called a geometric series. Take care, everyone.